Hello guys, today we have reverse engineering CTF challenge on Hack the Box, impossible password which is marked as easy. We will proceed to download the zip file. Okay, we will extract here, the password is Hack the Box, and we got the binary. I'll simply cut it and paste it right into my Linux subsystem in the impossible folder I already created. Okay, so going into the terminal, it's here. Okay, so first we'll start by analyzing the type of the file, and we see that is a 64-bit ELF executable. Okay, dynamically linked shared object for GNU Linux. Okay, let's try running it and see, but first we have to give it permissions. So okay, now we'll run it to see what it does. So it prints something like this. Okay, so it prints our output. Okay, if we try to give it some bigger output, okay, so it prints only some part of our output. We'll look into it to see what's the thing. First, I think it will be good to run some, or maybe we read the ELF data from it, from raw data. Let's see if you, okay, super secret key. Okay. So maybe if we go and if we type here super secret key, how is there? Okay, so it prints super secret key and then it prints another asterisk. So two asterisks. Yeah. Okay, now it doesn't print nothing and the program exits. Okay, let's try. We'll try running some strings on the binary to see if we got something more. Okay, so we have the super secret key here, and really nothing. We have an srand. Okay, time. Oh, okay, so I think it's an encryption by generating a random seed and getting the seed as the current time, maybe. Put char. Okay, here is what is printed right here after the first input. Okay, so right now let's try go and read a file with RAID 2. We can do so. We open RAID 2, R2 -a and the name of the file. Okay, let's go read the main function first. Good. So. Okay, here we see the declaration of the super secret key variable, some other variables declared after it, doesn't matter really. Okay, here is the scanf. Here is the print right after the scan, okay. And here is the comparison, okay. So this goes through and jump if equal to 0x 400 925. So maybe it's a call to another function. Okay, vdi1. Okay, 0x 408. Okay, and prints it. So then, okay, it prints two asterisks basically. If this goes through, basically it prints two asterisks for announcing the next input that it expects another input. So here is the second scanf, and yeah, like I said, it's reading into a buffer of 20. So it's just a buffer of 20. And move VDI is 14 in hexa, so it calls the function after with 14 in hexa as an argument. Okay, and then what it does, the return of that function is compared here with our input. So okay, so let's get again. We figured out the first input. Okay, the first comparison, it goes through the first level, let's say like that. Okay, and then what it does, it's reading another input from the keyboard, and then with the 14 in hexa as an argument, it goes and calls this function. The return of that function is basically compared to what we have what we input from the keyboard. So okay, and then what it does, testing ex, and then jump not equal. So if this is not equal, basically it jumps to 0x 400 976. So that's a little bit strange because it's jumping to another function if it's not equal. So okay, so basically if it's not equal, which is our case, it's jumping to this function 0x 976. So basically I think this is a function that stops the running of our program. So this needs to be jumped right here. Okay, so it never gets here because what we input from our keyboard, it's impossible to be equal with what is returned from this function call. So basically this is always jumping here to this function call, and it's basically exiting. Okay, so where I think we basically need to get, it's to this function call 00 400 978. So if we basically can get here, I think here the flag will be displayed. So basically what we can do, it's let's jump to that instruction. So jump not we will modify basically the opcodes here. So we'll go to this memory address, so 0x00 400 968. We'll get there. Let's print the first 10 so we know we're there. Okay, we are jump not equal, and then we will write the we will override these two memory addresses. So what we basically want, it's the program to, when he gets to that to these instructions, it's basically to do nothing. So jump over them, because then we want to get here. It's moving rx to rdi, and then calling this function, which I think will get the flag. So in order to do this, we need to override these two instructions, and to do this, we'll use, I think it's wx. We are pointing to this memory address. So wx 1990, 19 is the opcode for NOP, not operation. So basically it isn't doing any operation, it won't do. And 1919 means it writes 90 here, no operation, and at the next memory address it also writes 90. So no operation will be executed here after overwriting. So we'll write and then PD10 to print the next 10, and basically WX 1990 it didn't overwrite. So let me check radare to overwrite. I forgot the instruction WX radare to overwrite instruction opcode. How to modify machine code. Okay. Let's see. So it's incrementing. Okay. Radare to R2 minus W. Oh, okay, so we have to start. So we basically need to start it in with the -w flag, which open files in write mode. So we basically can't write it if we don't open it in there. So we'll just exit, and then R2 minus W impossible password bin. So PDF at main. Yeah, we can, because basically it can be found because we have in write mode. So basically what we will do is go to that memory address here, which we went the last time, which is 0x00 400 968. We can there PD10 to display the next 10 instructions from where we point this memory address. And now we will just overwrite 1990. Okay, and now if we print, we see that these two instructions, which were jump not equal to this function and load effective address, so whatever is at RBP minus 40 in hexa into RAX, will be overwritten with NOP opcode, so no operation. When it gets there, basically it won't do nothing. So this being said, now we can exit, and let's try see what we've done. Impossible parser is super secret key was the first one, and now doesn't matter what input, it will reveal the flag, and it does indeed reveal the flag. Okay, this is the flag. We go here and just submit the flag. Let's see. Okay, it was this is submit the flag, and you see I already solved it. So okay, this is the episode today, and I hope you liked it.